Assalamu alaikum. Hello and welcome. Today I'm going to present how I'm going to teach online and provide a real life like experience. The first question is state Kirchhoff's first law. It says choose a pen. The current entering a junction is equal to the current leaving it. Now, if we look at the second question, it says that the variation with potential difference of the current I for a resistor X and for a semiconductor diode are shown in the figure. Determine the resistance of the diode for the potential difference V of 0.6 volts. Now, for 0.6 volts, the current is 7.5 milliamps. So I can write something like this: I equals to V over R. It says 0.6 over R, and R comes out as 0.6 over 7.5 into 10 to the minus 3. It will give you 0.6 divided by 7.5 raised to the power minus 3. It gives you 80 ohms. Now, the next question is describe qualitatively the variation with of the resistance of the diode as V increases from 0.6 to 0.75 volts. Now, if we look at the graph itself, at 0.75 volts, the current is close to 15 milliamps. So, if I can look at the relationship, it says 0.75 divided by 15 raised to the power minus 3. The resistance is 50 ohms. So, here, because he's asking for a qualitative analysis and not asking for a quantitative analysis, we just have to say whether the resistance increases or it decreases. Here, the resistance actually decreases. Now, switch off the pen and move to the next page. It says the diode and the resistor are connected in the circuit. The cell has electromotive force E and negligible internal resistance. Resistor Y is connected in parallel with the resistor X and the diode. The current in the cell is 9.3 milliamps. Use figure to determine E. Now, when you're talking about a current of 7.5 milliamps, the voltage across the resistor is 0.3 volts. So since in a series circuit, the voltage divides, so the total voltage will be 0.3, 0.6 plus 0.6 rather, and it will be 0.9 volts. Now switch off the pen and move to the next page. And I can write 0.3 plus 0.6, that is 0.9 volts. Now he's saying that determine the resistance of resistor Y. I can say the current through Y can be calculated as 9.3 10 raised to the power minus 3 minus 7.5 10 raised to the power minus 3. It gives me 1.8 10 raised to the power minus 3 amps. So IY is 1.8 milliamps. Now I can find the resistance RY, which is equal to V upon I. So V in this case is 0.9 volts and I, you can say, is 1.8 milliamps. I can calculate the final result, which will be 0.9 divided by 1.8 raised to the power minus 3. It says 500 ohms. Calculate the power dissipated in the diode. The formula for power is I squared R. I is, in this case, is 7.5 milliamps. And R, as we calculated earlier, is 80 ohms. So I can find this thing, 7.5 raised to the power minus 3 whole squared times 80. And you should always provide the answer in standard form. The answer comes out as 4.5 milliwatts. That's it. And I'd say the cell is now replaced by a new cell of EMF 0.5 volts and negligible internal resistance. Use the figure to determine the new current in the diode. Switch off the pen and move to the back page. Now I have to draw a horizontal line because the diode and the resistor Rx are in series, so the same current will be flowing through both the devices. And the thing is, I can switch on the pen once more. If we draw a line right here, it says 0.4 volts across the diode and 0.1 volt across the resistor. So the total voltage sums up to 0.5 volts. So we can write the answer, that is 2.5 milliamps. End of story. Thank you very much.